All right. Okay, there's my dot plot. Room 30 on. That's on. Why is that? Source search. What? On.
Are we getting a homework packet today?
Yeah, but we're doing this first. Come on. Try again. Room 30 on. Turn it off, turn it back on. There we go. I don't know why that works, but apparently in life that's the ticket. All right. Sorry for the technical difficulties. If I could have your attention up this way. First, we need to name this dot plot. What are all those X's?
Cereal dot plot.
Cereal sugars.
Amount of sugar in cereal.
Should it be grams of sugar?
That's great. I'd go ahead and put the grams in parentheses. That's how you show units a lot of the time. Okay. Number 3, analyze the dot plot. What conclusions can you draw the amount of sugars in one serving of breakfast cereal from the plot? So we've already answered that question, but we were just looking at a list with names. 7 is
Approximate average.
the approximate What else can we say now that we're looking at it lined up this way? They are all basically to the left, which is actually low in sugar compared to, like, the top number is 22, but just because we have 1 in 22 doesn't mean that's a pattern for all of them. And so here's one pattern or one conclusion, here's another. What else could we say? It's another conclusion now that we have them lined up, looking at them in this format. A lot of them to the left. 7 looks like the approximate average. Why did he say 7 was the approximate average?
That's the most cereals.
7 is the number with the most occurring sugar amount. All right. Okay. Jordan states, Brian, could you read about Jordan?
Jordan states that those numbers on the number line that do not contain any data value should be eliminated. Tony disagrees and says that all the numbers on the number line must be included even if there are no data values for that particular number. Who is correct? Explain your reasoning.
Okay, so if we're making one of these dot plots, Jordan is saying, why in the heck did we put in 14, 15, 16 numbers like this if we don't even have any sugar that have them? Maybe we should make a plot without those numbers and just skip from 13 to 22. That's what Jordan says. Tony says, no, it is important to show all of the numbers on this line, whether they have a serial that has that amount or not. Your job right now, decide, are you on Team Jordan or Team Tony?
Tony.
Do you think you need the numbers, or do you think we could get rid of numbers that don't have serials? At your tables, you're doing an answer right now to number 4 at the top of the next page. Number 4. Okay, let's take 2 minutes. Talk to the people around you. Keep the numbers, get rid of the numbers. What would be an advantage or disadvantage of either method?
Left. You're definitely team.
You're good.
What's your problem?
It's like right now, 4.0000.
Okay, write something down now. What do you guys think?
To make me talk. Like on my TV video.
It's showing like how much it is, like how far away.
Yeah, to make it like
So visually you can see the distance.
So it like kind of makes me realize that it was bigger than sugar.
Okay. Right, good. Get something written down. What does this group think?
So honestly, you're just working. Thank you.
She's going with Tony. Why do you like what Tony said? Why do you think it's important to have those other numbers even
Right, and I feel sure,
or serial? Okay, so it makes it easier for your eyes to see the pattern.
Memo.
Hey,
Guys,
Read on Tony.
good. Write it down. What you agree, and then tell me why. Okay, why do you agree with Tony? You guys. Okay. Okay. All right, finish what you're writing. Let's see what our vote would be. Jordan, Tony. Mostly you voted as a table, so let's just do a table count. Oscar.
So Tony, your name wrong. Yeah.
This Tony is Tony with an I. Thank you.
Hey, I think
There we go. Jordan or Tony? Oscar. One table for Tony.
They went with Jordan, I went with Tony.
Okay, so we've got a split table. So here we go. That's all right.
Tony.
America.
You use it, Jordan.
Jordan.
Oh, so we kind of are. We are kind
What
of.
about Sam?
Think of America.
Just be Tony.
Yeah, so go for
Then
Jordan.
you get the win.
Jordan is a white man.
Brody, not all right. No, it's not a joke. It's not funny. Okay. So here we go. Talking about cereal. Jordan, Tony, all right. We as a group are kind of in the middle here. So who's a Tony group? Tell us why you think Tony.
I believe Tony because he is way more organized.
So you think keeping the number is more organized, okay? Somebody in the Jordan camp, yes.
Oh yeah. We don't need to write the access numbers. We can just do a squiggly line. So we're getting rid of the stuff we don't need.
Don't need the excess numbers, okay? That maybe a squiggly line or something is something you don't need, okay? Somebody else in the Tony group. How is having those numbers helpful? We're looking at the reason why. So along with being organized, how do you think keeping all the numbers is useful? Yes.
For me personally, when I see a number line and I see like it jumps from numbers, it like messes up my concentration and thinking. So that's why I like.
So with the numbers, easier to concentrate or easier
just
to...
like having it there, like being like, oh, there is no number 2.
With numbers, easier to see. Okay. How about Jordan? Anybody else want to give their reasoning why they thought, go ahead, get rid of them?
It's easier to look at.
Okay, so without it spread out, you think it'd be easier to look at. Okay, so less numbers, easier to look at. We're going to look at a lot of ways of organizing data, and you may pick a certain method in a certain situation to help show something, to make it easier one way or another. Okay, middle of the page here, when you analyze graphical display. Okay, someone to read for us. Thank you, Brody.
When you analyze a graphical display, you can look at several characteristics of the graph and draw conclusions. For example, you can ask yourself, what is the overall shape of the graph? Does it have any interesting patterns? Where is the approximate middle or center of the graph? How spread out are the data values on the graph?
Thank you. Christian, the overall shape.
The overall shape of the graph is called data description. Data description is most data the shape of the distribution can reveal non-distribution of data. There are many different distributions of this. Common are skewed right and skewed left.
Okay, so these are 3 patterns that you see often in graphs of this sort. Symmetric, skewed right, skewed left. Describe the patterns. So number 5, symmetric. When you're looking at symmetric, what do you see?
The
When
highest
I hear
numbers
the
in the
word
middle.
symmetric, I think of a circle.
Highest in the middle. Now they're kind of in a circle, but these ones, I wouldn't really call that this shape a circle. What else could we say about symmetric?
Even on both sides.
Thank you. What other things in life are symmetric?
Pictures.
These desks.
Oh, sorry. I thought you were like asking what
Yeah, what kind of pictures?
symmetric pictures. like a box. Yeah. Like a
So draw a triangle.
Okay, so some pictures are. What else is symmetric? Has kind of a middle and it's even on both sides.
These tables.
Tables. What else?
Computer.
Okay. It's interesting how Andy. How about look at the face across from you?
No,
That's what I just said.
mine's crooked.
Is it? Are
Yeah,
they
My
symmetric?
entire body is crooked. It's like lopsided.
Okay. But for the most part, do we have a middle?
Yeah.
Are things kind of even on both sides? For most people, pretty
Unless you have,
much.
like, a finger in the mouth or something.
One eye, one ear, one hand. We're symmetric. Okay, what else is symmetric? Where there's kind of a middle, and if you like fold the sides together, they would match.
Or square.
Squares and circles, okay? We're talking about what does symmetric mean. These are going to be some terms that we use, and the symmetric should be probably the easiest. You've heard it before. What about things out in nature? What else is symmetric out there?
A leaf.
No.
Thank you. A lot of leaves are symmetric, some maybe not. Okay. A worm. Interesting. So here's a leaf. It has a middle, and for the most part, the two sides we could probably fold together, and they, for the most part, match. Okay. What else has a middle, and if you brought the sides together, they would match?
A bird's wings.
Oh, thank you. So here's a bird, and there's one wing, there's another wing. Oh, this is not art class, okay? But we can imagine a line and wings coming together, okay? Okay, now, here's ones that'll be different and new. Skewed left and skewed right. Take a look at the figure first for skewed right. What do you see skewed right?
It's leaning to the right.
Is it? Look. Is skewed right leaning to the right?
No, it's higher
It
down.
goes down.
Decreasing out of right.
Leaning
To the right.
to the right goes down on the left, and skewed left, it's the opposite. It's leaning to the right. It goes down on. Wait, did I just say the right thing?
It goes up.
Oh, leaning to the left. Oh, did
No,
wait.
that goes to the right, and it goes up, not down.
Wait. Wait. I got leans to the right. Did I do the wrong? I did it wrong on the other one. Okay. Skewed right is leaning to the left. Goes down on the right. Skewed left is leaning to the right. It goes down on the left. All right, so one thing to notice that is, these are going to be a little hard to remember. If it's skewed to the right, that's where it's going down. If it's skewed to the left, that's where it's going down. There isn't as many on that side. The skew is that number, like in our cereal, that 22. What was true about 22? Take a look at your plot. Was ours even? If I was going to draw something like this, it's lopsided, okay? It's symmetric right here, but we still have that data point. Okay, so which one is this?
It's neither.
No, it's skewed to the right. Here's the skew. So the skew talks about where is the point where things are far off. Okay? Rather than being symmetric, something that's skewed is out of the pattern, out of the normal. Okay? So Here's skewed right. Skew is on the right. It's all by itself. Okay? Here's what they have to say about this. Actually, I don't know if I want to look. Yeah, we've got time. Kenya, could you read what they say about symmetric distribution?
In a symmetric distribution of data, the left and the right halves of the graph are nearly mirror images of each other. There is often a peak in the middle of the graph.
Okay, peak. Peak. And what does peak mean?
Top.
Top, highest point. Thank you. And a skewed right. Martine.
In a skewed right distribution of the data, the peak of the data is to the left side of the graph. There are only a few data points to the right side of the graph.
Okay, so skewed right means there's a few points on the right. Skewed left means there's only a few data points on the left. So the word matches the side where you don't have very much. The peak is actually on the opposite side. Okay, describe the distribution of the sugar amount. Explain what this means in terms of the problem situation. You guys write an answer to number 6. Is it symmetric, skewed left, skewed right? Talk at your table. We kind of drew a little picture. Number 6 for the on page 457, our sugar data. Was it symmetric, skewed right, or skewed left?
Less sugar.
Ooh.
He's drawing.
No.
Okay, well, number 6. Names are important, but finish number 6. What did I say? You got 4 people here.
Pretty sure she did screw to the right.
Do a British accent.
Try and remember why. That means.
No, it's definitely.
Stop. Don't put it away yet.